It says find the domain. Now remember, with the logarithm, the argument must be positive. So that means what you're taking the logarithm of, that's what the argument is, has to be positive. So that 3x plus 2 has to be positive. 3x has to be greater than negative 2, or x has to be greater than negative 2/3. Now here, the exponential by itself, his domain is all real numbers. So the problem is going to come with the exponent. I look at the exponent, this domain of x squared plus 2x minus 5 is all real numbers. So 5 to something that's domain is all real numbers is all real numbers. Any questions on domain? Because this is going to come back at you over and over and over and over. This is not the end of domain. Solve the following equations for x. Now here you notice that the base is the same. So the exponents have to be equal. So what's the first thing you need to do?
Times 3.
Yeah, clear the fraction. Multiply both sides by 3. So the 3's reduce out. This says that x plus 2 equals 9x. Or the 2 is equal to 8x. Subtract 1 from both sides. Divide both sides by 8 so that x is 1/4. Not a problem because the domain of this guy is all real numbers. He's an exponential. Now this is more complex in some ways than what we did yesterday. So 9 can be written as 3 squared, and this is to the 2x, my mask is getting away here, minus 5. And 27 can be 3 cubed to the 4x plus 1. Properties of exponents says you're going to multiply these two. That's the idea of a to the m to the n power is a to the m multiplied times n. So 3 to the 2 times 2x minus 5 equals 3 to the 3 times 4x plus 1. Now I would actually do this step. I wouldn't try, knowing that you can multiply these two. The error that I see most often is that you would say, oh, well, this is 3 times 4x plus 1, and then you come out writing 12x plus 1 instead of multiplying the 3 times the 1 also. So this way, there's no doubt. The bases are the same, so the exponents have to be equal. So 2 times x minus 5, or 2x minus 5. 2 times 2x minus 5 is equal to 3 times 4x plus 1. So 4x minus 10 equals 12x plus 3. And so subtract 12 from both sides, I get negative 8x minus 10 equals 3. Add 10 to both sides, so negative 8x equals 13. Then divide by, oops, let me paper stuck here. Then divide by 8, or negative 8, so that x is negative 13/8. Key is to make the bases the same. Bad news is, in most application problems, the bases aren't going to be the same. But that's a topic in 4.6. Now here we rewrite the logarithm as an exponential, so that 3 squared is equal to the argument, or x squared minus 27 equals 3 squared. X squared minus 27 equals 9. Or x squared equals 36. Take the square root of both sides. So what do I have to do? Don't forget the plus or minus. So that x is plus or minus 6. Now I need to check, because this is a logarithm, and my issue is x squared minus 27 must be positive. I can't take the log of a negative number. So if x equals 6, 6 squared minus 27, well, that's positive, so that's one of them. And if x equals negative 6, negative 6, the quantity squared, minus 27, that's certainly also positive. So negative 6 is also 1. The biggest problem you'll have is it makes the argument negative. Now we can get a little bit more picky, but not so much in this class. Now for interest's sake and for future reference, I'm going to turn my paper over just for the heck of it. If I wanted to find the domain of the log of, let's see, what was that, base 3 of x squared minus 27, what would I need to do?
Change it to x.
Yeah, no, not in this case, because I want to find the domain.
Oh.
What do I know about what has to be true of a logarithm?
Speed greater than
0, yeah. So the argument must be greater than 0. X squared minus 27 must be greater than 0. Now what do I do? Solve for x, solve the equal equation, right? That's 3.6. So x squared minus 27 equals 0. There's no domain restrictions. The domain of x squared minus 27 is all real numbers, so no problem there. This says that x squared equals 27. Or x equals plus or minus the square root of 27. So x equals the square root of 27, and x equals minus the square root of 27. Now what do I do? I want to know where this is positive. How do I check it? Number line, right. Put on negative square root of 27. 27. Now, what do I know the square root of 27 is close to? What number is it close to? 5, right. Right, the closest square is 25. So it's a little bit bigger, it's between 5 and 6, because 6 squared is 36. So it's a little bit more than 5. So I'm safe, I can pull x equals 0. But if I needed to pull a test point from here, I'd have to pick something like 6, because I know it's greater than 5. And since I don't know clearly whether it's 5.2 or 5.3 or 5.4, you want to have it bigger than 5. But 0 is my favorite, so 0 squared minus 27, that's negative. Negative, and these are both multiplicity 1, positive, positive. Notice negative 6 plus and minus 6 are both in this region where I've shaded. Negative 6 is over here, or positive 6 is over here. That was the answer that I got. And negative 6 was over here. So what's the domain? The domain is minus infinity, negative square root of 27, square root of 27, infinity. That was the big gun. 3.6, the big gun. In chapter 3, that's the big gun. Of all of chapter 3, the most important thing that comes out of chapter 3 is 3.6, because it's going to deal with domains over and over and over and over again. Any questions?
Pages on number 2, with the exponent, so you were saying that the exponent was all real numbers?
Mm-hmm.
Is that...
Because it's a polynomial.
Okay.
Now, what would be the difference? I'm going to pull another sheet of paper here. Is that if I had this instead, now when I look at the exponent, can x not be? It can't be 1. But in this particular instance, the exponent is x squared plus 2x minus 3. Its domain is all real numbers. So the domain of an exponential function can be dependent upon the domain of its exponent. That changes the domain of the exponential. Otherwise, the domain of the exponential is all real numbers. But in this particular instance, because the exponent has an exclusion, the exponential has an exclusion. The solution set has an exclusion. The exponential has an exclusion. So yeah. And that's why this guy didn't have a problem, because I made sure the denominator, there was no x down there. If there was an x down there, I would have had to check my answer. But that's a little picky thing.